Hello everyone, my name is Namrata Verma, Assistant Professor in the Electronics and Telecommunication Department at Sri Santosh Rungta Group of Institution, Rungta College of Engineering and Technology, Bhilai, Chhattisgarh. In the previous video lecture, we discussed about different types of amplitude modulation technique like double sideband full carrier, double sideband suppressed carrier and single sideband suppressed carrier along with their advantages, disadvantages and application. Today we are going to discuss about another type of amplitude modulation technique named as vestigial sideband generation and detection. In today's lecture, we cover the topic with the following point. First, we see the objective of this lecture, then overview of amplitude modulation technique, then introduction of vestigial sideband, advantages and disadvantages of vestigial sideband, generation of VSB, demodulation of vestigial sideband and then application of VSB, and at the last comparison of VSB with other modulation technique. First we will see objective. The basic objective of this lecture on vestigial sideband, which is also called as VSB modulation, is to provide a comprehensive understanding of the modulation technique, its principles, application and significance in model communication system. The first objective is to review the fundamental concepts of modulation, including amplitude modulation and its variant like DSB, SSB and VSB. Next is an introduction to vestigial sideband modulation, then illustrate the process of generating and transmitting a VSB signal with its mathematical representation along with the advantages and disadvantages of VSB. Now, let us see overview of amplitude modulation. Amplitude modulation is a technique used in electronic communication, most commonly for transmitting information via a radio carrier wave. There are several types of amplitude modulation technique, including double sideband full carrier, that is DSB FC, double sideband suppressed carrier, that is DSB SC, and single sideband suppressed carrier, that is SSB SC, and vestigial sideband, that is VSB. DSB FC is the standard form of AM in which both the carrier and the sidebands are transmitted. The bandwidth of the transmitted signal in the DSB FC is twice of the highest frequency of modulating signal, that is twice of FM. In DSB SC, the carrier signal is suppressed and only the upper and lower sideband are transmitted. The bandwidth is the same as in DSB FC, which is twice the highest frequency of the modulating signal, that is twice of FM. In single sideband suppressed carrier, only one of the sideband, either upper sideband or lower sideband, is transmitted along with the suppressed carrier. The bandwidth is reduced by half in case of SSB compared with DSB FC and DSB SC. Now, next is introduction to vestigial sideband. In traditional AM, a modulating signal is used to modulate both the upper sideband as well as lower sideband symmetrically around the carrier frequency. However, in VSB modulation, one sideband is significantly attenuated or vestigial while the other sideband is preserved. Vestigial sideband, that is VSB modulation, is a type of amplitude modulation technique which allows transmission of one sideband in addition with a part or vestige of other. Along with the upper sideband, a part of lower sideband is also being transmitted in this technique. Similarly, we can transmit the lower sideband along with a part of upper sideband. Basically, VSB is compromise between DSB SC and SSB SC modulation. It is a form of amplitude modulation that reduces the bandwidth required for transmission. Vestigial sideband modulation is a type of amplitude modulation technique that is commonly used in television broadcasting and other communication system. Now, introduction. VSB technique was introduced to overcome the drawback of SSB modulation, as SSB modulation require an accurate ideal filter to transmit only one sideband completely. Single sideband modulation is well suited for transmission of speech because of the energy gap that exists in the spectrum of speech signal between 0 and a few hundred hertz. As it is clear from this figure that there is a gap between lower and upper sideband, for this type of signal SSB is suitable. When the message signal contains significant component at extremely low frequency, as in the case of television signal, where there is no gap between the upper sideband and the lower sideband, and the upper and lower sideband meet at the carrier frequency as shown in this figure below. This means that the use of SSB modulation is inappropriate for transmission of such message signal owing to the practical difficulty of building such type of filter to isolate one sideband completely. This difficulty suggests another scheme known as vestigial sideband modulation, that is VSB, which is compromise between SSB and DSB-SC form of modulation. Vestigial sideband modulation is a modulation technique which allows transmission of one sideband in addition with a part or vestige part of other sideband. A guardband of very small width is laid on other side of VSB in order to avoid the interference. From this figure, it is clear that there is a guardband after upper sideband and vestigial sideband which avoids interference. This figure illustrates the spectrum of a VSB modulated wave S of t in relation to that of the message signal MT, assuming that the lower sideband is modified into vestigial sideband. From the figure, it is clear that the spectrum of VSB modulated wave have upper sideband with frequency range Fc plus Fm and some portion of lower sideband with range Fc minus F of V. Now, the bandwidth of VSB signal will be the difference between the upper frequency and the lower frequency, that is bandwidth will be equal to difference of Fc plus Fm minus Fc minus Fm, or we can write bandwidth is equal to Fm plus Fv, where Fm is the maximum modulating frequency and Fv is the frequency of the vestigial sideband. Now, let us consider one example. In standard television broadcasting, the VSB signal typically occupies a bandwidth of about 6 megahertz, with the vestigial sideband occupying a small portion of this bandwidth, often around 0.75 megahertz. This setup allows for efficient use of the spectrum while maintaining the quality and integrity of the transmitted video signal. Now, let us understand why VSB is required. There are mainly two reasons for using VSB. First, it enables more efficient utilization of transmission bandwidth, unlike SSB modulation, which transmit only one sideband containing half of the information, whereas VSB transmits portion of sideband, thereby they free up the available bandwidth for another signal. Bandwidth conservation is one of the key advantage of VSB modulation. In SSB modulation, the ideal filter was required to eliminate unwanted sideband. However, it is impossible to design such ideal filter with zero attenuation, as there is no guardband between the upper sideband and the lower sideband is available in the modulating signal. As a result, some of the unwanted sidebands was always present in the SSB modulated signal. This is one of the main challenge in SSB modulation. To overcome this challenge, practical filters are used with some attenuation. These filters are able to eliminate most of the unwanted sideband, but not eliminates the sideband completely. As a result, SSB will always have some distortion. Therefore, VSB is used. In phase shift method, for SSB generation method, carrier signal is phase shifted by 90 degrees to generate the upper sideband and lower sideband. However, it is not possible to achieve exact 90-degree phase shift of carrier signal in practice due to carrier is affected by noise and other factor. Because of that, carrier signal is not perfect sinusoidal. As a result, phase shift will slightly off from 90 degrees. VSB modulation are less susceptible to interference from the other signal, and VSB modulated signal have good signal to noise ratio. So, the advantages of VSB modulation include efficient use of bandwidth, improved signal to noise ratio, less susceptible to noise and interference, less cost generation method. VSB modulation is compatible with existing AM receiver, while VSB demodulation are complex than standard AM demodulation method. VSB modulation requires quite higher power as compared to SSB or QAM, and it can be more power efficient than standard double sideband AM due to the reduced bandwidth requirement. This can be advantages of VSB modulation. Now, let us see some disadvantages of VSB modulation. VSB modulation is more complex than other modulation scheme. It requires more careful tuning of transmitter and receiver. VSB modulation typically requires high transmission power compared to SSB or QAM modulation. VSB modulation is not as widely used like SSB or QAM. These are the disadvantages of VSB. Now, let us see the generation of VSB. Let us see the next part of the lecture, that is block diagram for the generation of VSB modulated signal. First, the message signal MT and the carrier signal CT generated from the local oscillator are applied at the input of the product modulator. The product modulator multiplies the message signal and the carrier signal and produced the DSB-SC modulated signal, namely Y of t. This DSB-SC signal is passed through a VSB sideband filter, which passes the one of the sideband along with the vestige of the other sideband. The output of VSB sideband filter is VSB modulated signal, which is represented by Y dash t. Now, let us see the mathematical representation of VSB modulation. Let the modulating signal is represented by M of t, and the carrier signal from the local oscillator is C of t, which is given by AC cos 2 pi fct. Now, these two signals are applied at the input of the product modulator. Then the output of product modulator is Y of t, which is product of MT and CT, or we can write Y of t, that is equal to MT into AC cos of 2 pi fct. Now, taking the Fourier transform of the above equation, then this equation becomes Y of f, that is equal to convolution of M of f into AC by 2 times del f minus fc plus del f plus fc, or it can be written as Y of f is equal to AC by 2 times convolution of M of f and del f minus fc plus del f plus fc, or it can be also written as Y of f, that is equal to AC by 2 times M f minus fc plus M f plus fc. Now, frequency response of VSB sideband filter is h of f. Then this signal is passed through the filter having frequency response of h of f, then the output of the VSB sideband filter will be y dash f, that is equal to AC by 2 times m of f minus fc plus m of f plus fc whole is multiplied by h of f, where h of f is frequency response of the filter used. Now, next is demodulation of VSB. Let us see the block diagram for the demodulation of VSB signal. First, the VSB modulated signal y of t and the carrier signal c t generated from the local oscillator are applied at the input of the product modulator. The product modulator multiplies the VSB modulated signal and the carrier signal, and the output of product modulator is passed through the low pass filter, which passes the frequency up to the message signal only, and then the output of low pass filter is nothing but the message signal m of t, which is the main concept of demodulation technique. Now, let the modulated signal is represented by y of t, that y of t is VSB modulated signal, and the carrier signal from the local oscillator is c t, which is equal to AC cos 2 pi fct. Now, both of these signals are applied at the input of the product modulator, then the output of product modulator is represented by z of t, which is equal to zt is equal to yt into ct, or it can be written as z of t is equal to y of t into AC cos 2 pi fct. By taking Fourier transform of the above equation, this equation can be written as z of f, that is equal to y of f convolved with AC by 2 times del f minus fc plus del f plus fc, or it can be written as z of f, that is equal to AC by 2 times convolution of y of f and del f minus fc plus del f plus fc, or z of f, that is equal to AC by 2 times y f minus fc plus y f plus fc. As we know, the VSB modulated signal is represented by y of f, that is equal to AC by 2 times m of f minus fc plus m of f plus fc whole is multiplied by h of f. Therefore, we can write y of f minus fc is equal to, simply we will substitute instead of f minus fc, then the expression will be y of f minus fc, that is equal to AC by 2 times m of f minus fc plus m of f plus fc minus fc whole is multiplied by h f minus fc, or it can be simplified as y of f minus fc, that is equal to AC by 2 times m f minus 2 fc plus m f, which is whole multiplied by h f minus fc. Similarly, we can write y f plus fc, which is equal to AC by 2 times m f minus fc plus fc plus m f plus fc whole is multiplied by h of f plus fc, or it can be further simplified as y f plus fc, that is equal to AC by 2 times m of f plus m f plus 2 fc, that whole is multiplied by h of f plus fc. Now, substitute this value of y f minus fc and y f plus fc in the equation of z of f. Then the equation of Z of f will be AC by 2 times y f plus fc plus AC by 2 times y f plus fc. Then the equation will be Z of f, that is equal to AC by 2 times AC by 2 into m f minus 2 fc plus mf whole is multiplied by h f minus fc plus AC by 2 into AC by 2 m of f plus m of f plus 2 fc whole is multiplied by h f plus fc, or it can be written as Z of f, that is equal to AC square by 2 m of f minus 2 fc plus m of f, that whole is multiplied by h of f minus fc plus AC square by 2 m of f plus m of f plus twice of fc, that whole is multiplied by h of f plus fc, or Z of f will be further simplified as AC square by 2 m of f minus 2 fc into h of f minus fc plus m of f into h f minus fc plus m of f into h of f plus fc plus m of f plus 2 fc into h of f plus fc. After passing this signal through the low pass filter, then the output of low pass filter will be Z of f, that is equal to AC square by 2 m of f into h f minus fc plus m of f into h of f plus fc, that will pass only the signal, message signal having the frequency f of m. That is why we have the component of m of f only. Then Z of f will be AC square by 2 into h of f minus fc plus h of f plus fc whole is multiplied by m of f. Let h of f minus fc and h of f plus fc is represented by a constant k. Now, the above equation will be Z of f, that is equal to AC square by 2 into k times of m of f, or Z of f, that is equal to k1 into m of f. Taking inverse Fourier transform of Z of t, that is equal to k1 times of mt, where k1 is equal to AC square by 2 into k, or Zt is proportional to mt. That means we can say that the demodulated signal, that is represented by Z of t, that is nothing but the message signal, that is nothing but the proportional of the message signal, which is our information that we have transmitted from the transmitter's end. Now, let us see the application of vestigial sideband. The first application is VSB is extensively used in analog television broadcasting system. It is also used in digital television broadcasting. The second one is VSB can be used in high definition radio broadcasting to transmit additional digital information alongside traditional analog signal. Next application, in some cable and satellite communication system, vestigial sideband modulation is used to transmit video and data signal efficiently. VSB can be also used in microwave communication system to transmit television signal over long distances. These are the applications of the VSB modulation. Now, let us see the comparison of vestigial sideband with other amplitude modulation technique. Now, we will see this comparison table. There is no, we will compare the VSB signal with the DSB FC, DSB SC and SSB signal. The first comparison is there is no carrier separation in double sideband full carrier and vestigial sideband, whereas carrier is fully suppressed in double sideband suppressed carrier and single sideband modulation. The second comparison is there is no sideband separation in double sideband full carrier and double sideband suppressed carrier, but one sideband is completely suppressed in single sideband and one sideband is partially suppressed along in the vestigial sideband. The transmission efficiency is minimum in double sideband full carrier, moderate in double sideband suppressed carrier and vestigial sideband, and maximum in case of single sideband modulation. Bandwidth is same, that is twice of modulating signal frequency, that is represented by twice of FM for double sideband full carrier and double sideband suppressed carrier, where it is simply f of m for the single sideband modulation and bandwidth is between twice of FM and FM, that is between double sideband FC and DSB SC and SSB SC for the vestigial sideband. Now, the power saving for the case of DSB FC, that is double sideband full carrier, is 0%. In case of double sideband suppressed carrier, power saving is about 67.7%. In case of single sideband suppressed carrier, power saving is 83.3% and vestigial sideband save the power about of 75%. In terms of power saving, the VSB signal saves the power maximum, that is about 75%. Now, the next parameter is reconstruction at the receiver end. The reconstruction, that is detection of the DSB FC, is very easy. Reconstruction at the receiver end of double sideband suppressed carrier is moderate, and in case of double sideband suppressed carrier, reconstruction at the receiver end is very difficult, and in the VSB, that is vestigial sideband case, reconstruction at the receiver end is also very difficult. So, at the reconstruction level or reconstruction point of view, we can say that the DSB SC signal reconstruction at the receiver end is very easy. Now, next parameter is application part. The double sideband full carrier is used in the radio broadcasting application. The double sideband suppressed carrier is also used in radio broadcasting. The single sideband suppressed carrier is used in point-to-point mobile communication, whereas vestigial sideband is used in television and other communication system. In conclusion, vestigial sideband is a modulation technique that significantly improves the efficiency of communication system by conserving the bandwidth and conserving the power, making it a preferred choice for the television communication and the other communication application. Thank you.